Hi everyone, in Algebra 3, today we're going to be going over your new material in lesson 78, and it's on something called the hyperbola. So we're going to be graphing this, and you're going to notice that the equation is going to look something like the ellipse, but there's going to be one key difference. Please excuse the lovely drawing on here. So the standard form of an ellipse with the center at the origin looked like this. The hyperbola is defined to be a locus of all points such that the absolute value of the difference of the distances from any point on the hyperbola to two fixed points is a constant. Okay, so this is the standard form of an ellipse. Now I'm going to show you what the standard form of a hyperbola looks like. It would look like this. So it looks almost exactly the same, but we're going to have a minus sign instead of a plus sign. So x squared over a squared minus y squared over b squared. So what I'm going to show you is that we're actually going to create a box using the a and the b. So taking the square root of the a and the b. A would be the distance on the x-axis. B, it would be the distance on the y-axis. Then we're going to create a rectangular box. And then what we're going to do is we're going to draw two diagonal lines through that. And we'll be able to find the equation of the slopes of both of those. And then if the x comes first, then we're going to open our parabola up on the y-axis, on the x-axis. If the y comes first, such as this one, y squared comes first, I would open it up on the y-axis, okay? And what's missing here is like this little rectangular box that will make it easier for you to actually graph. So I'm going to show you what that's going to be. So basically it's two parabola opening up on the y-axis away from each other. So what we're going to do is we're going to do the example to sketch the hyperbola. X squared over 9 minus y squared over 4 equals 1, and find the equation of the asymptotes. So those diagonal lines that I was saying are called the asymptotes. So I'm going to do x squared over the square root of 9 minus y squared over the square root of 4 equals 1. So it's in the correct format. Now all I need to do is I need to graph this. So okay, so I'm going to extend these actually. On the x-axis, I'm going to go through away from the origin. On the y-axis, I'm going to go 2 away from the origin. And now I'm going to connect this box. So you're going to make a rectangular box that looks like that. And now we're going to put in the asymptotes, which are going to be diagonal lines that are going to go through the two corners and the center. Okay, like that. Now it does want the equations of both of those. That one's really bad. But this would be y is equal to rise 2 over 3. So 2 over 3x. That's the same thing, but it's going to be the negative. So when it asks for the equations of that, it's just the rise over the run. And they're going to be exactly the same, one positive, one negative. And now you're going to draw your hyperbola, which because it has the x comes first, you're going to open them up on the x-axis. So it looks like this. And you're going to use your asymptotes kind of as your guidelines. And that would be your result. So now what we're going to do is I am going to have you do numbers 7 and 8 on your own, or do number 7, try number 7, then watch the video, do number 8, then watch the video so that we can see if you know what they are. So for number 7, I'm going to do for the x-axis, I'm going to take the square root of 16. The y-axis, I'm going to take the square root of 4. This one asks for the coordinates of the vertices as well as the equation of the asymptotes. So we'll do both. Okay, so it's going to go 4 away on the x-axis, 2 away on the y-axis, and when I create my box, it would look like this. So really the box is just your guideline for making your asymptotes. So they should slope through like that, and then slope through like that. The equation of this, these two asymptotes, is going to be y is equal to rise 2 over 4. So it would be 1/2 x. This one would be the same, just negative. So those are the two equations of your asymptotes. Your vertices are going to be these 2 points right here. So I'm going to just say it's going to open up on the x-axis because the x comes first. So it should look like this. And your two vertices, I would say, are 1, 2, 3 over 4 up 0. So it would be 4, 0 and -4, 0. So these are your answers, including the diagram right there. Now looking at number 8, it's going to be similar, but we have to do a step first before we can actually graph this. So what we're going to do is we are going to put this into standard form first, and then we'll go into actually diagramming it. So what I'm going to do is I have to divide everything by 36. So I have, for number 8, I have 4y squared over 36 minus 9x squared over 36 equals 36 over 36, which is 1. So this would turn into y squared over 9 minus x squared over 4 equals 1. Now I'm going to graph because I can take the square root of both. Okay, so this is going to go square root of 9 is 3, so I'm going to go 3 away. Square root of 4 is 2. Then I'll create my box. And then put my asymptotes in. Other one. This one says that it's, because the y comes first, it's going to open up on the y-axis. So it looks like this. And the equation of your asymptotes are going to be y is equal to rise 3 over 2. So 3 over 2x and -3 over 2x. Then my two vertices are going to be 0 up 3. So that would be 0, 3 and 0, -3. And that would be all your answers. So now what I'm going to do is I'm just going to start going through some of these problems. I think the best way for you to actually learn would be for you to actually do the problem, attempt the problem first, then press play for you to do the rest of them. So for number 16, the first thing that I'm going to do is I am going to solve for angle A on number 16, and then I will set up some ratios. So for number 16, I'm going to solve for angle A, which would be 180 minus 130 minus 20, which means that A is going to be equal to 50. Now I'm going to set up my ratios, which are going to be the side opposite the angle constitute a pair. So I'm going to do B over the sine of 130 equals 6 over the sine of 20 equals A over the sine of 50. No, that should be 30. My bad. I don't know what I was thinking. A should be equal to 30. Because 180 minus 150 is 30, not 50. Okay, so now I'm going to start by cross multiplying the first two. So that would be B times sine of 20 equals 6 times sine of 130. You will divide both sides by sine of 20, so I'm just going to go 6 times 130 sine equals divided by 20 sine equals, and you will end up with, for B, 13.44. Now for A, I'm going to do A times sine of 20 equals 6 times sine of 30. So 6 times 30 sine equals, then I'm going to divide that by 20 sine equals. So A is going to be equal to 8.77. So capital A is equal to 30. Lowercase a is 8.77. B is equal to 13.44. Now looking at number 17, we are going to draw an ellipse, but we have to get the standard form first. So similar to getting the standard form of a hyperbola, we're going to have 49x squared over 196 plus y squared, 4y squared over 196 equals 196 divided by 196. So 196 divided by 49 is 4. So that would give me x squared over 4 plus y squared over 49 equals 1. I'm going to do the square root of both. And this will be tall and skinny. Okay, so it's going to go 7 away on the y-axis and 2 away on the x-axis. So your ellipse is going to be very, very skinny oval. And that is number 17. Now for number 18, we are going to, remember, cross or multiply down left and then minus from top right to bottom left. So number 18 would be d plus 2 times d plus 2 minus 3d minus 1 times d minus 4 equals 0. I can multiply this side out, so that would be d squared plus 4d plus 4. This part, though, is going to be more tricky, but it's going to be negative 3d squared plus 12d, because don't forget about this minus sign, plus d, and then minus 4 equals 0. So when I combine that, I can get negative 2d squared, 4d plus 12d plus 1d, 13, plus 17d, and then the 4's actually cancel. So now to solve, I can factor out a d. So that would be negative 2d plus 17. So I have two answers. I'm going to set each equal to 0. So negative 2d plus 17 equals 0 would be negative 2d equals negative 17, which means that I get d is equal to not only 0, because d equals 0, but also equal to 17 over 2, and that's positive, not negative. So it'd be two negatives divided by each other. And that's what number 18 looks like. Now moving on to number 19. The parabola has its vertex at negative 2, negative 6, and its focus at negative 2, negative 4, or negative 2, 4. Write the equation of the parabola, the directrix, the axis of symmetry, and graph the parabola. So I'm going to graph first. Okay, so we're gonna go negative 2 down 6. So 1, 2, 3, 4, 5, 6. This is gonna be my vertex. My focus is negative 2 up 4, which means that my axis of symmetry will be the vertical line that goes through each of those points. So it will tell me that my axis of symmetry is that x is equal to negative 2. Now for my directrix, it's going to be the same distance away as the vertex to the focus. So there's currently 10 spots between the vertex and the focus. I'm going to go down 10. Should be here, and I'm going to put a horizontal line. That's going to be your directrix. And your equation of your directrix is going to be y is equal to negative 16. Now your parabola should look like this because it's going to open up towards your focus. And then I need each of my points for my equation of the parabola. So the parabola is y is equal to 1 over 4p x minus h squared plus k. So the p is the distance between the vertex and the focus. So if I count up, that's 10 spaces. And then the h and the k is just the coordinates of the vertex, which the coordinates of the vertex is negative 2, negative 6. So that would be x minus negative 2 plus negative 6. So your answer these are your answers too, your axis of symmetry, as well as your diagram. Your last answer is going to be y is equal to 1 over 20, x plus 2 squared minus 6. And that's number 19. Now looking at number 20, I'm going to start by just sketching the diagram of just y is equal to negative, or y is equal to log 10x, not including the negative. So when I convert this on number 20, it's going to become x is equal to 10 to the power of y. And now I'm going to be plugging in values into y instead of into x. So it's going to be negative 1, 0, and a 1. So now when I plug in negative 1, this is going to become 1/10. When I plug in 0, that's 1. When I plug in 1, that's 10. But basically what you're doing is you're making all the y's negative. So instead of it being negative 1, this is going to positive 1. Instead of 1, this is going to be negative. So when I diagram this, it would be positive 1/10 up 1 over 1 up 0, and then over 10 down 1. So this should be what your exponential form looks like. And that's it. So I didn't plug in that negative sign until after I already evaluated for the positive of it. It does make that easier. Now number 21, it says find the radius and the coordinates of the center of the circle, whose equation is 3x squared plus 6x plus 6y. The first thing that you should recognize on this problem is that you could actually divide everything by 3. So when I do that, and then I put the x's together, that would be x squared plus 2x. And then plus y squared plus 2y. It would be equal to 11. Now half of 2 would give me x plus 1. When I square that, that's plus 1 that I'm going to add to both sides. Again, half of 2 is going to be 1, so that would be y plus 1 squared. Add 1 to both sides. So that would be equal to 13. Now the coordinate of the center of the circle is the opposite of what's given, so that would be negative 1, negative 1. And my radius is equal to the square root of 13, which would be hard for me to diagram, so I'm just going to plug that into my calculator. It's going to be about 3.6. So I'm going to graph this. Okay, so I'm going to go -3 or -1, -1. That's the center. And I'm going to go just over 3. So 1, 2, 3, just over 3. 1, 2, 3, just over 3 would be about here. Then 1, 2, 3, just over 3, be about here. Then 1, 2, 3. And that should be your circle, which looks like a weird oval. Okay. Now looking at number 22, it says write the equation of the sinusoid whose graph is a sine function that has been shifted 3 pi over 2 to the right. And that has an amplitude of 4 and a period of 3 pi and a center line at 5. So for number 22, y is going to be equal to a, which is 5. A is 5. Amplitude is 4. It's a sine function. It's 2 pi divided by the length of the period, which is 3 pi. And they say it's moving over 3 pi over 2 to the right, which means that I need to shift this over. It's going to be x minus the phase shift, which is 3 pi over 2. So now all I have to do is simplify these pi's, and my answer is going to be y is equal to 5 plus 4 sine 2 over 3 x minus 3 pi over 2. And that's it. So it gives you everything you need without actually having to look at a graph. Now looking at number 23, we need to multiply these together. And when I do so, add multiply, which would give me 6 CIS, and 10 plus 15, or 10 plus 5 is 15 divided by 9 would be 5 pi over 3. I do need to expand this, so that's going to be 6 cosine of 5 pi over 3 plus I sine 5 pi over 3. My over 3 chart looks like this. 1, 2, 3. Starting at 0, I'm going to count 1, 2, 3, 4, 5. That puts me in quadrant 4. When it's over 3, it's a 60-degree angle. So it'd be 1, negative root 3, 2. Cosine is going to be adjacent over hypotenuse, so that would be 1 over 2. Sine is going to be opposite over hypotenuse, which would be negative root 3 over 2. Then all I have to do is distribute my 6. So I will get 3 minus 3 root 3 I. So all that was a reference triangle. Now moving on to number 24, which is going to require us to put this into radians, not into degrees. So I'm going to start by moving the 1 to the other side. So it gives me cosine 3 theta equals negative 1. Now, this is actually going to use a unit circle. So 1, 0, 0, 1, negative 1, 0, 0, negative 1. If I underline all the x coordinates, that tells me that cosine is equal to the x coordinate. And the only place where the x coordinate is equal to negative 1 is at 180 degrees. So I'm going to start by setting 3 theta equal to 180, which means that my first answer is theta is equal to 660. And I probably should have done that in radians. So it's actually going to be 3 theta is equal to pi, because pi is equal to 180. When I divide that by 3, my first answer is going to be pi over 3. Now I need to find out my other answers. So I'm going to set 2 pi equal, 3 theta is equal to 2 pi, because 2 pi would be equal to 360. I'm going to divide both sides by 3. So if I add 2 pi over 3 to pi over 3, I would get, I'm going to do it again. So it would be theta equals pi over 3 is my first answer. Second answer is just going to be pi, because it's 3 pi over 3. And then 3 pi over 3 plus 2 pi over 3 would be 5 pi over 3. Now, if you would have done this in degrees first, you would have had to then convert it into radians. So if I left it as just 60, I would have needed to multiply this by pi over 180. That's how you convert from degrees into radians. So you just multiply each one by pi over 180. That would have also worked for number 24. For number 25, I need to separate these two equations. I'm going to have cosine of 2 theta equals 0. And I'm going to have cosecant theta equals 1. Now, both of these are going to use the unit circle. So I'm going to draw my unit circle. 1, 0, 0, 1, negative 1, 0, 0, negative 1. Now cosine is equal to the x coordinate. Cosecant is 1 over y, which means I'm looking for where the y coordinate is positive 1, looking for where the x coordinate is 0. Now, the x coordinate is equal to 0 at 90 and 270. So that means that my first answer is going to be 2 theta would be equal to pi over 2, because 180 divided by 2. And then 2 theta is going to be equal to 3 pi over 2. Now, if I divide both sides by 2, or multiply by 1/2, my first answer is going to be theta is equal to pi over 4. My second answer is going to be pi is equal to 3 pi over 4. Remember, though, that I'm going to have another answer for each of those quadrants. So I'm going to set 2 theta equal to pi. So when actually 2 theta is equal to 2 pi. I'm going to divide both sides by 2, which would just give me pi. So if I add pi to pi over 4, that would give me 5 pi over 4. If I add pi to 3 pi over 4, that would be 7 pi over 4. So those are your 4 answers that satisfy the first one, but now I have to do the second. So where is the y coordinate equal to 0? There are 2 places. That would be at 0 and 180. So those 2 answers would be just 0 and pi. Because remember, pi radians is equal to 180 degrees. So those are going to be altogether your 6 answers that are going to satisfy your equation, which I think I have a typo here. Cosecant 1 over y. Oh, I'm just kidding. Sorry. There should be 1 over the y coordinate. I'm not looking for where it's 0. I'm looking for where it's equal to 1. My bad. So that would only be up here, which means that your answer would be theta is equal to pi over 2. So sorry, my brain is not awake yet. So these would be your 5 answers. So not these, because I looked at 0, which is wrong. I should have looked at for where it's equal to 1. Now let's move on to number 26. So I'm going to start by evaluating the parentheses, the cosine of 240. So 240 is going to be in quadrant 3, the 60-degree angle. So it'd be -1, -√3, 2. So that would turn into arc cosine of -1/2. Now, when we're dealing with arc, we don't use quadrant 3, and we're looking for where cosine is negative. Well, I know cosine is positive in 1 and positive in 4, which means that my triangle I'm drawing is going to be in quadrant 2. The adjacent is -1, hypotenuse is 2. This is still going to be a 60-degree angle, but because it's in quadrant 2, I need to subtract it from 180, which means that my answer for A is going to be 180 minus 60, which is 120. So throwing it back to those arc problems. Now moving on to the second one. That's in radians, which means my answer needs to be in radians. So for B, I have arc sine of the sine of 5π/3. If I do this over 3, that would be 1, 2, 3, 1, 2, 3. Counting away, so 1, 2, 3, 4, 5. That puts me in quadrant 4. And that's a 60-degree angle, so that's going to be 1, -√3, and 2. So the sine of that is going to be opposite over hypotenuse, so I end up with arc sine of -√3/2. But if I draw my 4 quadrants, all students take calculus. I don't use quadrant 3. Sine is actually positive in 1 and 2, which means that I can only actually draw this triangle in quadrant 4, which I've already done. So therefore, my answer is just going to be the original problem, which is 5π/3. I don't have to redraw it because I already know what it's going to look like. It's going to look exactly like that. So you kind of lucked out on number 26, part B. You have less work to do. Now, number 27, we are going to find I'm just going to start by finding the median and the mode. Then I'll do the mean, the standard deviation, and the variance. The reason I'm doing that is because I'm going to use my calculator for all of those. So for the median, it's the middle number. So it's the middle number between 3 and 5, which would be 4. The mode is the number that shows up the most, which would be 5. Now I'm going to start finding the mean. So I'm going to do second 7 to clear my calculator. It says error. That means there's nothing stored. Now 1, 2, 3, 5, 5, 7. So there's 6 values in my calculator. To find the mean, you do second x squared. So that gives me 3.83. Standard deviation is second divide, which gives me 2.03. And the variance, I just square that, which is 4.14. So number 27, almost all done in your calculator. Number 28, I have to find the distance between a point and a line. So I'm going to start by solving this equation for y. So for number 28, I have y is equal to -1/4 x plus 1. And the point that I'm looking at is -1, -2. So step number 1 is to find the perpendicular line of this. So that would be y equals 4x plus b. Plug in my points. So -2 equals 4 times negative 1 plus b, which means when I add 4 to both sides, I'm going to get b is equal to 2. So my perpendicular line is going to be y is equal to 4x plus 2. Step 2 is to set these two lines equal to each other to find out where they're going to intersect. So that would be negative 1/4 x plus 1 equals 4x plus 2. You can multiply this whole thing by 4 to get rid of the denominator. Should be negative x plus 4 equals 16x plus 8. So if I move the 16 to the other side, I get negative 17x equals 4. Which means that x is going to be negative 4 over 17, which seems like it's going to be a nightmare. Now, part 3 is to solve for y, so you have to plug that into one of your equations. So let's just plug it into the perpendicular line. So that would be 4 times negative 4 over 17 plus 2, common denominator. So it's 17 times 2 minus 16 would be 18 over 17. So now what you're going to do is you're going to use the distance formula using your original point and your two intersecting points. And that would give me the distance is equal to the square root of x1, which is negative 1, minus x2, which turns into plus 4 over 17, plus negative 2 minus 18 over 17 squared. So I'm going to end up with negative 17 plus 4 would be negative 13 over 17 squared, plus, okay, so 2 times 17 negative minus 18 would be, yikes, negative 52 over 17 squared. That will turn into 169 plus 2704 over 289. So 169 plus 2704. That does not divide evenly. So let's try this. So 2704 plus 169 divided by 289. Nope. I think I did something wrong. Because the square root of 17, let's try, okay, so let's do 169 plus 2704 equals, divide that by 169. Okay, so that would be 13 square root of 17 over 17, and that would be your result. Okay, now we only have two more that we're going to do. So number 29, the first thing that I'm going to do is there's a number outside my logarithm, which means that I need to move that to the exponent. I also am going to make a common denominator within here. So that would be ln of x squared minus ln 4x minus 1 over 4 equals ln of 4. The minus sign means I'm going to divide, so that would be ln of x squared divided by 4x minus 1 over 4 equals ln of 4. So to get rid of the ln, I'm going to raise it to the power of e. And then I'm going to multiply the 4 times the x squared. So that's going to be 4x squared over 4x minus 1 equals 4 over 1. So when I cross multiply that, I'm going to get 4x squared equals 16x minus 4. If I set that equal to 0, I get 4x squared minus 16x plus 4 equals 0. That is all divisible by 4, so that would be x squared minus 4x plus 1 equals 0. Unfortunately, that does not divide evenly, which means I have to do the quadratic formula. X equals negative 4 plus or minus the square root. Negative 4 squared minus 4 times a times c all over 2 times a. So I'm going to get 4 over 2 plus or minus 16 minus 4, which would be the square root of 8 over 2. So that would be 2 plus or minus root 2. What does it say? Plus or minus root 3. So I did 416 x minus 4. Bring it over, makes it negative. Divide it all by 4. X equals negative b plus or minus square root b squared minus 4 times a times c. Okay. I'm going to leave my answer as that because I'm not sure how they got, unless I have a typo. Okay, moving on, let's look at number 30. It's going to be the last problem we're going to do. So for this one, I have a number outside my logarithm on both sides. So that would become log 2x squared plus log 2, 5 equals log 2, 3 squared. Now there's a plus sign in between, so I have to multiply those. So that's going to be log 2, 5x squared equals log 2, 9. I'm going to raise both sides to the power of 2. So I get 5x squared equals 9. Divide both sides by 5. And take the square root. So x would be equal to 3 over root 5, but you know you can't leave the square root of 5 in the denominator. So your answer is going to be x is equal to 3 root 5 over 5. And that concludes the problems that we're going to do on lesson 78. This is the last lesson that you are learning for the year, so congratulations, you made it. Have a great day. Bye.